So those are 5 specific examples of what I'll call discoveries that are already on the table. And the real question is, what does it take to now evolve these discoveries out of into repeatability? First of all, you have to have ready access in order to repeat these, have them done by different investigators so that there's no question about the objectivity of the investigations, have them independently reviewed and published, and so on, in order to hit the mainstream of a given scientific area. And that's what the next step is about on space station. Will we get the opportunity to do that? Well, there's, I think, 3 things that will regulate the productivity of the International Space Station. One we've already heard about, and that's transportation. My personal view of the transportation scenario is it's workable. Between the assets that are already in place in Russia, Europe, and Japan, and the assets that will be proven and demonstrated in the next 12 to 24 months here in the United States, we will have up mass and down mass to and from the space station. There's still a risk there, but we will have that obstacle overcome. The second obstacle is, do you have sufficient resources and accommodations on orbit? And I think you saw from Gerst's discussion this morning that there's very, very little question that we've got the laboratory capacity on orbit. We've got the laboratory capacity, we've got the transportation assets. The last thing that we need is we need the funding to be able to repeat the experiments, demonstrate the proof of concept, move it into the mainstream, where it's not just a esoteric NASA investigation, but it's something that other industrial communities are looking at as a potential competitive advantage in their fields. That's the stage we have to get to. And you heard a lot of discussion this morning about, well, can we take the federal funds and can we leverage those better into commercial investments in order to move down that pathway? And that's a slippery slope. You've got to hit it just right. If there is no federal investment or a weak federal investment in the proof of concept phase, there won't be any private investment. So we've got to make that commitment against all of our competing priorities to strengthen the government's investment, and we work with all of the government agencies to try to encourage this, but to strengthen the government investment in the basic research so that we can have a better probability of success in bridging that research into the mainstream markets where the private sector can pick it up and run with it. Now we have 10 decades ahead of us. Based on the results I've seen up until now, we could reach a tipping point by the middle of the next decade. If we get the support that we need and the transportation arrives on schedule, there's little doubt in my mind that we could reach a tipping point, and then we can all go home, and literally the private markets will take it over from there. And that will, by the end of this decade, accomplish one of the main purposes of the space station, to develop a new economy in space. It's within our reach, but we have to make all the right decisions. So let's go to the last slide, and then I'll wrap up before I step too bad on the panel coming next. This is a bit of a riddle. What have we learned since the 20th century discovery of vacuum processing? Now, I was going to play a little bit with the audience on this, but we don't really have time. So what I'm going to tell you is what we have learned from that industrial revolution is that environment counts. Environment is a major contributor in certain industrial revolutions. We would not have microelectronic devices today if it weren't for vacuum processing technology. And at the end of the 19th century, as scientists were beginning to poke into vacuums and learn how to form them and learn how to measure them, and they started getting some crazy ideas about how vacuums might have useful applications, people laughed at them and said, that's ridiculous, it's nothing. How can nothing ever have a value? And yet we had a 20th century industrial revolution result. So I think the same type of thinking has to be applied to this new environment, which is not just the absence of matter. I mean, we're up there working in a vacuum, the absence of matter, but now it's the absence of force, in addition to the absence of matter. And if that's not a profound change in an environment, and if we as a species cannot figure out how to take that change and leverage it into applications, we're doing something wrong. So with that, I'm going to close and turn it over to our National Lab panel, which is a terrific panel that I'm sure you'll have fun listening to. Can I take a question or two?
Mark, I have a question. Thanks for your examples of the discoveries so far. I hope you put them on the astronautical website so that we can have access to those.
This will be broadly distributed.
Okay, great. My question is, examples are good to show people, discoveries coming down the pike, but I was wondering if you have more hard criteria for success of the International Space Station, more of a quantitative measurement per se. Would it be something like the number of papers published or the number of patents that come out of it? Or have you given any thought to that kind of a success criteria?
Yeah, no, we have developed an exhaustive set of measurement metrics that will go along with how we characterize the progress of this nonprofit organization that we're going to be setting up. And it's complicated enough that it's not one single metric. In fact, I'll give you a good example that I like to tell people about. Let's talk about published papers. Well, most people now know that published papers are not what's important. It's the citations to those published papers. So we're putting in place the tools in the coming year that will allow us to measure the citation impact of the papers that are produced as a result of space station research. So that's one dimension just in the basic science area. But clearly, patents, intellectual property agreements, licensing agreements is probably the single greatest metric that you can use in today's environment, because patents aren't what they used to be. The licensing agreements are where the money, the rubber hits the road. And then there's a whole series of metrics that will go with that. Other questions? For those of you that are interested in this nonprofit organization, we will be holding an open day with the public on December the 10th at NASA headquarters in Washington, D.C., where we will take questions, we will take advice, and we'll try to have a free exchange of ideas in preparation for the final stage. As many of you know, we're already embarked on a competitive acquisition of a cooperative agreement, and this is the next step in the road. This public day that we'll be holding on December 10th. Okay, thank you very much for your time.